let's look at the basic naive approach for forecasting. For naive approach, you really don't need a estimate sample and a holdout sample. So your naive approach would be, if you want to start forecasting right from the first possible naive forecast, you have to leave the first one entire cycle alone. So if you did not worry about seasonality, then the forecast for the second period will be the forecast for the actual of the first period and so on. But that's not obviously the right approach when you have seasonality. So you have to go back to the previous same season. So you have to leave the first one entire cycle blank, and so you go back 12 periods to the same January of the previous year. So that's your forecast for 1992 January, and so on. So now you can copy this all the way down, and those will be the forecast. Of course, if you want to extend further, then you can extend further up to one full year of naive forecast. Okay, so this is the naive model. Another model is the average model. The average model, we can have estimate sample and holdout sample. Here, suppose we want to use estimate sample of 1991 to 2005. So from 1991 to 2005 is what will be used to estimate. So here the approach is the average of a given month for all the data that we have in the estimate sample. And so you have to average all the Januaries in the estimate sample from 1991 all the way up to 2005. And that will be the forecast for January for 2006. For February, again, you average everything from 1991 to 2005. And that will be the forecast for February. Now we can get this done very easily using pivot table. And once again, let's set up the pivot table. So starting from here, and we want to go all the way down to 2005, starting from 91. So up to the end of 2005, that's our estimate sample up to December of 2005. So for the first three columns, insert pivot table. Now let's put the pivot table right here. Okay, so now we want the month over there and the temperature here, but we don't want the sum of the temperatures, so we need to go into value field setting and change it to average temperature. Okay, so let's do some formatting. We don't need so many decimal places, so let's reduce the decimal places. Okay, now we have the average from the estimate sample, and those averages are then the forecast for 2006. Okay, so that's going to be G40. Okay, so I prefer to type this when referring to a cell inside a pivot table, because if you simply do equal to that, it gets get pivot data, which is okay, but I prefer this. Okay, then those are the forecasts for year 2006, the average of all the Januaries in the previous sample data set, and so on. Now we want to compare these forecasts with what actually happened in 2006 using 2006 12 months as the holdout sample. Now for that we need to get the actual values. The actual values for 2006 is in a column, but we want it in a row, so you have to take those 2006 values and express them put them in a row, so you have to use the transpose function, and for that first highlight these January through December cells and then start the function transpose and go to 2006 actual values starting from January through December. Now close parenthesis, but don't press enter. Now you have to do Control Shift, keep the Control Shift pressed, don't let it go, and then press enter, and that will enter the transpose function for us, and that will give us the actual values. So now that we have the actual values on the forecast, we can compute the error, which is actual minus forecast. Then we do an absolute value of the error and square the error and average these to find the accuracy measures. But we really don't need to do that because we have our functions, remember, from chapter 3. So we'll be using those, but just to be consistent with the textbook, which your textbook has this information in table 4.1. So I'm just reproducing it here. Okay, so this is our basic baseline forecast, not the average, but the baseline forecast is a naive forecast. So all other forecasting methods for seasonality should at least be able to do better than the naive forecast. Otherwise, there is no need to go into all those complexities. We might as well use the naive model. So we'll get into more detailed models from the next video.